let's define a function that computes the sum of all the elements in the array. So we are going to have integer return value, compute sum version 1, int values array, and then size of the array is given, begin with a 0, go through all the elements, we accumulate into the sum, and then return value the sum. So this is the logic how to add all the numbers. And then we have learned that to receive an array in a function as a parameter, we define this way. This was the syntax we have learned. So let's compute what is actually sum. 1 plus 2 plus 2 for 5 is the sum of the elements in the data array. And then let's use assert and then compute this version 1. That is a sum is there. And then we need to give a prototype of a compute the sum 1. So int compute sum 1, then array, and then size is there in prototype. The name of the array is optional. The size of the parameter name is optional as well. So let's compile the program and then run it. Everything looks okay. Now let's define a function differently. That is int compute sum version 2. I can receive an array using pointer syntax as well is there. So int star, so this is a pointer which can hold the address. And then when you call, so let's call assert with the compute sum 2. The data is the name of the array, which is the address of the first element in the array. So that value can be stored into a pointer, since array is a pointer which is holding address of the first element in the array named data. The 5 is the size. Then when you accumulate all the elements in the array, we can use a pointer arithmetic beginning with a 0. So array plus a 0 is a address at element at index 0. When I is 1, this part becomes array at index 1 and the like. So we can compute the sum and everything should work fine. We need a prototype. When you define prototype, sum 2, since the first element is a pointer, so we can define int star there. So if I compile and run, everything looks okay. Here, when you define a function parameter with this notation, it is quite different from the array definition. Array name is constant read-only, so you cannot do something like a variable operation there. But when you define function parameter with this notation, but in this case the values is not array name, but it's a pointer with a different syntax. So this syntax and let me to keep the contents, let me copy that and then comment this line out. So originally this is the one we defined, but since the values in this syntax does not mean it's name of the array, but it's actually pointer declaration, same as this. So you can do as a pointer and like this. So this syntax or this syntax and this syntax are just syntactic difference, but meaning of parameter name values is actually pointer. So another observation is that if a pointer is given the address of the array, then you can use array index notation, meaning that the name of the pointer is initialized to the beginning of the array, then you can use a pointer as if it's array name. What I mean by as if array name is you can use index notation to have access to the elements. So that's another semantic of C++. So if I compile and run, there's no difference using this way or that way. So since the values is a pointer, you can use something like this. Array is a pointer, but this is also pointer. So what I can do is I can comment this. Instead, let me use sum like that. Since value is a pointer, we can compute this way by having access to the array using the pointer arithmetic. So make and run. So there's no difference. So that is the meaning of a parameter as defined as an array. Then it is actually a pointer there. So let me define another version, compute sum 3, where I define array in the size there. Then here you can compute the value. Since this is let me have another assertion calling sum3, and then let me give sum3 pointer. So in a prototype definition, giving this syntax or that syntax is actually identical. So let me copy that and then comment out and then use this syntax. Actually same thing. So for your preference, you can use this way or that way because the pointer parameter is nothing but a pointer there. So compute sum3, compute the sum3, compute the sum. Here's typo, so everything is okay there. So let me compile and run to verify everything is okay. So in compute 3, what I want to change a little bit is since array is a pointer, you can use as if the array name, so you can have index access like this. So also you can use dereferencing. Since array is a pointer, we can use a dereference, and then after that we can increment the pointer. So this is equivalent. So here in the version 3 and the version 2, you can use it this way or that way. Everything looks the same, same effect that you get. So for your preference, you can use either version 1 or version 2 and version 3. They are all identical. Make and run. Everything is running okay.